Welcome to a new test and teardown video. This time it's another Hewlett Packard. The 16702A logic analysis system. Yeah, so it's a logic analyzer for all sorts of microcontroller digital systems and stuff like that. And I think it is from 1994. I found one on eBay for $400. And this unit here is 16.7 kilograms. I've been trying to look up the specifications of the system. And I think it's a proprietary microcontroller data systems, something like that. It's not a personal computer compatible unit. So it's running its own operating systems and all that kind of stuff. This screen should be 800 by 600 pixels and it should be full color flat screen panel. So that is definitely something for 1994. 10.7 inches. Whoa. And a full keyboard on the front. This one should be defects. So what kind of defects? I actually don't know. My unit is not fully equipped. I think we can plug in some more I/O modules or some other kind of modules. Pro power. Oh, we also got a 2-channel oscilloscope here as well, right? And then we of course got 2 units. And they support, I think that will be 2 pots and 2 pots. And then again, so we can handle quite a lot. And I think it's 8 bits per pot, right? 32, so it's 64 bits. And then, of course, this super expansion port. It looks a little bit like a personal computer compatible keyboard mouse. We also got another, I don't know exactly what that is doing. External VGA monitor, serial and parallel LAN, and external hard drive, and T-base LAN. So that will probably be their personal computer or their proprietary computer that is in here. I don't know yet. I think we should probably just open and have a little look before I try and power it up. You never know the state of stuff, and it's always a good idea just to do a little bit of visual inspection. Just don't blow it all up by plugging stuff in that has been lying down in somebody's basement for 20 years. I mean, this one was last checked, see, 2011. So that is definitely some years ago. I'm still doing my little inspection round. And something mega puked. So there's some serious leak. And this one seems to be coming from this point. So there's probably a long leakage something. This is something I definitely need to inspect. What is going on here? Oh, look at that. Some big nasty chips with 1,000,000 pins. And that is the expansion slot going all the way around there. Oh, and we got plenty of unused space in there. Very big fan. And all those expansion slots. This one can really be filled up with a lot of goodies. And up here we also got some modules. What the? Ah, is that the power supply? That is a funny location for a power supply. I'm still hunting for the leak. So of course I need to remove all the plugins. So that will just be some spares. And the fun thing is, that'll be the logic analyzer plugins. But look at that. the flat cables here, they interconnect the two units like that, so they need to be pulled out at the same time. That is some funny design. So I pulled all the cards out and I got bad news. Well, now I know where the leak is coming from, and that means I'm not able to repair this unit. That is just how sad it is. But I think we can still enjoy the fantastic Hewlett Packard design, and that at least count for something. So this will be the 2 giga samples 2-channel oscilloscope plug-in module, and from this side it looks really nice and beautiful. We got the 2 input modules and amplifiers and all that kind of stuff, and I think this will be a custom analog to digital converter or something like that. Probably got some clock sampling stuff, and it could also contain some memory, right? Because we don't have any other local memory chips on this board. See, that will be some thick film custom chips. But look at that. Everything here is completely corroded, and it's that bad all over the place. See? So this was left outside in the rain or something like that. This is how bad it is. Or some chemical or something was dropped. See, and then it just slime, and then it just corrodes everything all over the place. Oops. So that is unfortunately the state of more or less everything in here. And that will be the data acquisition inputs. Look at that, we first go into all those chips. That's just more or less all the bits, for probably 4 bits per chip. Maybe this is trigger level and some nicing up, amplifying, driving, impedance matching, and then we go, of course, time length matched, and that will be some FPGAs handling all the sampling. And now we go super wide into all the memory, and this is how you make it fast. Go wide. That is just amazing. There'll be some clock and PLL chips. See some clock distribution, amplifying, and some more clock handling here. That is a reference clock in out. This one is 100 megahertz and a 19 point something. I don't know exactly what they're doing right there. We got a little local switch mode converter. The 2 boards, they are more or less identical. They're interconnected in a really weird way. But that is obviously what makes it top and bottom. And again, bottom side, we got the other 4-bit per chips. And again, we see some corrosion that's been dripping down, leaking everything. It's probably all the pins with voltage on, because we got some battery backed up chips. So I think my first attempt will be to try and power it up without all those modules plugged in. As you can imagine, this is not good at all. But what if the rest powers up without these modules in? So now I will continue to investigate the rest. They made it so you could replace the computer board. Just pull this out. Because of course the future is another computer that is bigger, better, faster, or something like that, right? I could easily imagine that. So this board here is the external SCSI, and now LAN is, yes, also connected to this board. And then we've got two flat cables like that. One is going to that hard drive, right? And then where's the other one going? Ah, it goes in and out. How funny. Aha! So from the SCSI controller, you go to that hard drive and back again to the other one, and then out like that. And then you need a termination probably here, right? Or that will be the termination. Oh, SCSI, don't you just love it? Oh, we got some missing screws right there. So I better be sure to plug this in. Well, good. I just measured 0 volts on this backup battery, so that is not a good sign. That is probably the main CPU, whatever that is. Of course, memory. And they are using their own special internal memory system for their CPU. And I believe there is another one on the bottom. I will have a look in a second. That will be the graphic output. And then it goes to a little graphic driver, a display driver, and that will be the flat cable to the display or something like that, right? It's gotta be somewhere down here. This is of course the Mega Magnum power supply, 600 watts. And I think this is a standard IBM compatible disk drive. So nothing fancy smancy about that one. And of course a quantum fireball. Good old SCSI. Yeah, I think I want to try and power this up now. I think I have seen enough for now. I think I'm done with my pre-round. I didn't find any other leaked stuff. Oh, look at all those fans. Yeah. 4 fans. Oh, nice, man. So maybe we should try and do this together. Of course, I turned it off here on the front. Let's try and turn on the $13 watts of standby. Why is it using that much in standby? Okay, let's do it. 120 watts. Oh, we got lines and stripes and funky stuff on the screen. So yeah, we probably got a ton of... Oop. Look at that. Yada yada booty booty. What are we doing here? I mean, yeah. It sort of is powering up. 126 watts. So I need to enter some sort of a command. What kind of command do you want me to put in here? Like run? Nope, nope. I'll probably have to look this up. What are you doing? What is saying this? This can't be good. Nah. This is not good. So I'm just doing another try with the power up and see if it's still doing that funky sound. Let's see. Dear. Oh. This is the hard drive. That is the problem. It's trying to spin. Yeah, there's a hard drive that is not I don't know anything about any commands. So, okay, we got a crashed hard drive. But I just had to try help. And see, we got all sorts of help. And it will tell all the different commands and stuff. So I think the CPU is working. But that is not so funny, is it? Well, I am at a point where I have, of course, realized that I am not able to get this thing to boot because I got crashed software, and there's just no way to make this boot, and I have lost all calibrations and I've lost all data anyway. So that is just not going to happen, and because all of my plug-in cards, they have been completely corroded and wasted, so there's nothing more to do than just look a little bit on how stuff was designed. So this will be inside the custom chips, and I think we can see how everything here is really corroded and all that kind of stuff. Oh, look at that sexy socket. So they're holding some pins in here. Aha, it's impossible to mount this wrong. Well, that is some sexy chip. That could be an important spare part. This one seems to be okay. And all the corrosion is probably only on the outside. This is probably also a chip you will find in other HP sampling oscilloscopes. We got some loose springy pins in here, and they're locked in between these two layers of plastic. So of course I'm not going to pull this apart and then they're going to fall on the floor, right? There's one more super cool thing I wanted to show you. This is the analog input for the scope inputs, right? Look at the relays that handles everything, and this is a complete 2 giga sample analog scope front end. When we take it out of the case, a multi-layer thick film with custom chipped and everything in here bonded. I'm of course not going to open this one because I don't want to damage it or anything like that, but it's just so cool. I'm still trying to see if I can figure out why it's not booting on the CSI drive. Is it due to power supply? Is it some data, or is it just a crashed disk, or is it this interface? Because I saw the missing screws here, so somebody was in here and tried to poke around with this one, so maybe the problem is here. And I just really enjoy the design. I've seen some stickers with 1998 on a few of the chips, so I think my unit is from 98, and you can see it here again. 98 is written on more or less all of these big babies here, right? Yeah, 89. Ah, that's some other stuff, right? It has to be 98. SCSI interface with everything here. Just fascinating. So I didn't find anything like leaked capacitors or anything like that. I want to inspect the CPU card as well. And then that will be the interface card for everything else. And it's full of connectors and it's beautifully made, I must say. And a lot of programmable chips all over the place. Let's look a little bit on the CPU motherboard or the whole computer unit. I mean, I probably already told you this, but I design circuit boards for a living. And I'm quite happy that I didn't have to do this one. Nasty. Look what they're doing here. So they got all those chips on top of other chips again. And this circuit board here is using good old through via technology. So that means it is of course a multi-layer, but a via, look at that, exists on all layers. So that means every time you put a via, you kind of restrict the area on any layer, right? So you really need to think. And also, this board here is from 98, but this unit was released in 94. And the computer programs in 94, they were not as smart as and fantastic as we have today. So, whoa, man. And also, look at the memory. Directly on top of each other like that. And since that was not enough, you have to add connectors like that and add more memory. How nice. Oh, let's see if we can get the heatsink off the CPU and have a little closer look. What is going on here? And that's the graphic output. So that's probably, that is the graphic chip right there. It is absolutely amazing. Yeah, the memory consists of both big ones and small ones, and that's because we got extra bits, probably priority bits. Oh man, it's nice. So here we go. That will be the main CPU. Another sexy custom chip. Also with HP logo on it. And the graphic chip is a BGA. .8 pitch or something like that, right? And then that will be a display memory for the, so that's a graphic card right there. This is nice. Oh, we got a little bit of a little oopsie doopsie here. And I think I found a few more. Yeah, here we go. Quite beautifully made. See, that will be some capacitors and some termination ringing something fixie. Thank you very much for watching. That is all I wanted to show you. I will park this unit for my storage right here and right now, and I can't do anything more until I get some spare parts or whatever happens. Bye bye.